Alright, here we're going to take a look at strings of C++, including the old C-style string, which basically is working with a char of arrays. So first we'll work with just the chars and creating arrays and show you how the methods that are built into the libraries work with those. Alright, so do all this, we need to include, as you see there at the top, C string, which is referring to the C-type strings. Alright, so all a string is working with characters, a C string as we call it. So if you have a char array, then we'll start with one here called first name, and we'll make it a size of 20. So that means it can hold 20 characters. Alright, which is important. Right? A char by itself holds only a single character. Right? Where a char array holds, in this case, 20 characters. So big difference. Alright, so first, how do you assign data to a variable of char type? Alright, so first name, I try to assign it in this fashion. Alright, start with that. Right. Gives you an error right away. You can see it there. If you try and compile it, it'll give you an error also. I'll go ahead and try and compile it there so you'll see the error. I'll bring that up in the screen in a minute. Alright, so there's our error, and let me resize this first for you. And you can see the error. Alright, there it is. Alright, can't assign to it that way. Does not like it. Alright, so we have to fix that problem. Well, with the C type strings, it's kind of painful if you're doing it in code. You have to tell it character by character because that's what it stores. What character you want to store. We're dealing with characters, so it's single quotes as opposed to the double quotes. Put double quotes, it will complain about the double quotes. And we copy and paste this here, save a little typing time here. You have to put in each individual character one by one. Alright, so we're just dealing with 4 here. We'll put the 4 in. And of course you got to change the locations. Right? So 1, 2, and 3. And there I'm going to put the I, the C, and the H. Alright, oops, lost my C out statement. Put that back in there. And you see I put a C out there for the end of program, so you see when we do reach it, as opposed to when we're getting errors of this crashing and stuff of that nature. Oops, semicolon there. Alright, so now this should compile. Let's see here. No problems there, but the output, as you see, is very strange. Got a lot of these crazy characters out here after the rich, which I did assign. If you count up all those crazy characters, that should add up to 20 or more. Because what it's looking for is it doesn't know when this ends. The string, right? The character. We said the array can hold up to 20, but we only gave it 4 values. So this is a lot of garbage values that are in the array. Right, so there's nothing to indicate where rich ends or when to stop. So the cout just goes ahead and prints everything that's on there until it finds what we call a null terminator. So when you're doing a char array of this nature in code, you're assigning values to it, you are responsible for putting in that null terminator. And that's how you put in the null terminator there with the /0. So now when this runs, we should only see the rich, which we see right there. Because the null tells the cout when to stop printing. There are another 16 characters. Well, the null's in there now, so there's actually another 15 characters in the array, or it could hold 15 more characters, but we didn't use them. So the null tells it where we stopped using the characters in the array when you want to deal with a string. Alright. Now that's hard coding it there and putting values in. We can also use input from the user. Alright, so we do something of this nature. So now we'll prompt the user to enter the first name. Alright, yeah, we don't need that there, we'll go there. And we'll use the CIN, and we'll use the get line method that's part of the CIN object. We give it the array name, and then how many maximum number of characters we want it to input. The array size is 20 at max. Right. Again, that null terminator is important. Alright. The get line will take care of that for us. Alright, so I can get the name, I'll put it again right after getting it, and I'll type in something different. So you see the first name be outputted twice with two different outputs. Alright, so let's run that now. Alright, so the get line automatically puts in the null terminator for you at the end of the input. So here it's prompting us for the name. This time I'll put my full name in there, and it prints my full name. So now the null terminator is after the D in the array. It doesn't print the null. It knows that's not a character with the print. It just marks the end of the string. Alright, so those are the two ways you can populate the array. It's simple. Alright. Let's take a look at one of the methods inside of the string library there that we can use. Let's create a variable here, size, that's an integer, and this method tells us the size of the array. Alright, so if we use the string length, that's what that stands for, str string, and then len for length, and we give it first name. Alright, size now has that value. We can output it. Let's see, put text here. Size is, and output the variable size. There we go. And we'll do that again after we get the input down here. Alright, run that now. So now we should see two different sizes. Alright, so there's the output with Rich and the size of 4, which makes sense for 4 letters, full name, and the size is 7 because Richard has 7 characters within it. Alright, one more thing I'm going to do here is, before we do anything with the array, tell you the size. Alright. And there you'll see that it gives kind of a crazy number there, 31. Size of the array is 20, but what size string length is doing is looking for that null terminator to determine how many characters are in it. So again, if I type in Richard, it gives me the correct values. Alright, so it's all based on that null terminator that we're worried about. Right, so that's the string length. The get line gets the characters, 20 being the max number of characters you want to get, and so forth. Alright, let's add some more arrays in here as we start showing you the other methods that are part of this C string. We will eventually need one for the last name that I'm going to use in this example, and then another one for full name. Alright, and semicolon. Alright, so one of the other methods that are out there, alright, is the string copy. So the string copies, str for string again, cpy, copies from one char array into the other. So I want to copy into the full name the first name. Right. So there you see it, and that will concatenate or copy whatever's in first name into the full name. Alright, so I'll save a little typing here. I am going to copy some code that I'm following into here for you. Alright, so I'm outputting what full name will have. Then I get the size of full name and I output the size. Sizes, full name size, let's do that. So we know that's coming from there. Right? So I'm not only still getting the input, all the inputs going to first name. I'm not doing any direct input to full name. It's just doing the string copy. Oh, errors, what did I miss? Oh, yep, an error I wanted to show you actually. Down below here, you may see this warning, and it depends on the environment and the configuration you have set up, because it tells you here that you can set this up to allow it. But they refined the library to a string copy underscore s. The book doesn't show it. It shows it with the string s, because that's the traditional way of doing it. But if you get this warning, something of this nature, you're going to want to just add an underscore s at the end of it. And that error should now go away. This should now compile cleanly. It's just warning me that I haven't used my last name yet. And there's our window. So the size so far is correct. Richard gives me a 7. Full name is Richard with full size of 7, just like we got with the first name. Alright, so that's one error. You may see it a couple times. Alright. If you don't remember to put in that underscore s, that's all it needs. Simple fix for a lot of things. Alright, so let's start using that last name. Get rid of that warning that we got going on there. Alright, so in this code, alright, I am getting the prompting the user again for last name. If max can hold is up to 20, so the same thing going on there. Now I'm showing you the string concatenation. Alright, so up here I copied first name into full name. So full name down here has Richard in it, and I'm going to tack in whatever I type in for the last name. So this string cat, str cat for catenation, combines the two strings. So last name will not be modified, but full name will be modified. It will maintain what it currently has and concatenate on to the end of it whatever last name has. So full name should display whatever the combination of the two names, and we should get a new size as we go along. And compile that. Alright. Oops. Drag that over so you can see it. Alright. First name. Alright. Is Richard. Alright. There's the normal information that we've been seeing. There's the prompt for the last name. And full name now has Richard Specioso with no space. I didn't tell it to put a space between it. Right? You're in control, so you would have to do that. But you see it did concatenate it. Full name there now has Richard Specioso. The size of it has changed. Right? So it brings the two strings together, but modifying only one of the two. Alright, another method that's out there, all coming from that C string library, is this string strcmp compare. That's what it stands for. You can see I have a couple cases here. I'm just using the first name and last name. This method, this str compare, will return a 0, an integer value of 0, so you can assign it to a variable if you need to, but it returns a 0 if the two strings are identical, 100% identical. It returns a negative number if the second argument, which in this case is last, is greater than the first argument, which is first name. If the first argument is greater than the second argument, it will give you a value greater than 0. So 0 when they're equal, a negative number when the second is greater than the first, and a positive value when the first argument is greater than the second argument. Or in other words, when first name is less than last name, and when first name is greater than last name. So I got to run this a couple times to show you that it's working, but I'm just going to keep using first name and last name there. So first time through, I will type in Richard and Specioso again. And it's telling me last name is greater than first name, which is true because Specioso starts with an S, which comes after the R in Richard. Right. Again, it's comparing characters by character. Running it again. This time I'm going to type in Richard and Richard. And it tells me the two names are the same, as expected. Now I'm just going to reverse the first name and the last name. So here where it's prompting me for first name, I'm just going to type in my last name, and where it's asking for my last name, typing in my first name, and now it tells me first name is greater than the last name. Remember the opposites? Alright, so first name is specioso, which it should be greater than because it comes after the R in Richard, which is actually in the last name. Right, so we can use those in if statements for comparing strings. You know, maybe they got a loop going, you tell them to type in the word quit. So now you can do a comparison if you're using char arrays for the word quit. Right, those type of scenarios. Anything else, if they're not doesn't return you a 0, then you keep looping because they haven't typed in quit. Alright, one other method to look at. Alright, let's start with this little piece here. Okay, we have this char pointer here. Right, it doesn't hold any memory, it's just a pointer to a location where there is a character. Not a string, but a single character this points to. Right, not a string. The new method here is str or string or substring. Right. Really what it's looking for. I give it this variable. It's looking for where there is an R. It needs two strings. That's why this is in double quotes, even though it's a single. I can put more than one character in there if I want. I can put in rich. Still works. And it's looking for where this string first appears inside this variable and assigns the pointer of where inside this array this starts. Not the entire thing, just the first character. So really it's just going to give me where the R is. Alright, so we can show you that. It's real quick here, compiling that. And then I output what these the content that the pointer is pointing to. Alright, and again, it's a pointer to a character, not a string. And you see it only outputs the R because it's a char pointer, not a string pointer. It's not pointing to the entire array, it's pointing to an individual character. So that's why I get the R. Alright, again, if I take off the rest of that and just use the R by itself, I get the exact same results. Alright. And there you go. Alright. So now though, if I change this to ICH, right? Oops, not ICH, ARD, the last part of my name. Again, it's just looking for that substring if it exists. If ARD is not in the string, it will not give me it will give you a null back. Right? The pointer will be null. So ARD is in my name. If I type in my full name, alright, then again the pointer is still only a char pointer, so it gives you a single character that it's pointing to, but it found it. Alright, so if I was to not, just to show you that you do get something else back, right? ARG, that string does not exist in my name. So when we run this now, alright, program's actually crashing. Let me drag that over so you see it. There it is. Alright, because I got a null pointer and I'm trying to use a null pointer in the cout statement, so it's going to crash the program. Alright, so you need to check for a null. Alright, that would be the safe thing before you do this statement. That will eliminate that. So similar to check for a null, again, alright, subname, as long as it's not equal to null PTR. Alright, we should be safe now. Alright, there's the window. Richard Specioso. Alright, and there it is, doesn't crash now, runs to the end, doesn't try and output what the pointer's pointing to because I avoided it. Alright, so this does give you a null back if it can't find it. If I just did the A, then it will find it, and I will get that A back, and I can print the A out once again. Alright, so the pointer is useful. Alright, we'll make this a little bigger here so we can avoid it. Alright, do some proper programming here for what I'm going to show you next. Still working with that pointer. Let's make this a valid pointer now. Alright, and all I'm going to do is add a while loop. Let me just copy that over. That's going to print everything from where the pointer is until it finds the null. Alright, that's what this is searching for. Alright, I'm incrementing the pointer. Remember from the last chapter, talking about pointers. Incrementing moves the pointer to the next location on RAM or memory. Alright, so I'm looking for ARD. I'm using that within, oops, sorry about that. Let me get that back open. There we go. There's our window. Alright. Alright, and there you see, there's the A from when I printed right here on this line, 59. Then I got ARD, which is coming out of this loop. So from the pointer, I kept going until I reached a null. If I put this back to the R, now I would see my whole first name. And of course, you change this to last name, you'll get everything to deal with the last name, first name, whatever it is. Alright, just to show you that quickly, that I will get my complete name out in terms of my first name. And there's the double R again, right, but there's Richard, completely done. Right. So again, it's a char array, so we can use the square brackets to get to the individual letters, just like we're doing up here when we do the assignments. Right. We can check for individual values within the char array. This is the old C string data type.